Does it hurt to get a word froze off?
No, it shouldn't. I don't know why we're talking. I just started recording, and the first thing you hear is, does it hurt to get a wart frozen up? Whatever. All right. Hi, Owen and Macy and Brady. We're going to do 44 and 48. This is on 1-4 homework assignment. And then we're going to finish the notes for 1-4. So they just had some questions on this one. Then we are going to do that. Then, after we finish 1-4 today, tomorrow we review for mid-chapter quiz. I have a review for you. Then we take mid-chapter quiz on probably Thursday because you're telling me all the juniors are gone Wednesday, okay? And then Friday we'll resume chapter 1, whatever, right? Okay, so number 44, slope of a line that is parallel to the x-axis. So x-axis is right here. Let's go with this line right here. Let's go with that line. That line is like y equals 3, let's say, right? What is the slope of that line? Well, if I just pick 2 points on here, right? How much, if I do rise over run, how much is it rising? 0, and it's running, let's say 5. I have no idea from those 2 points, right? So this guy will have a slope of 0. It is undefined when the line is going up and down because it doesn't pass the vertical line test. It's not a function anyway, right? Okay, so answer to number 44 is 0. If this thing has a slope of 5/8, right? And instead it goes 216 in the vertical, how much will it go in the horizontal? So you could do this with a proportion, right? But which one of these is horizontal and which one is vertical? Horizontal is the bottom one. This is horizontal, vertical, it's rise over run, right? So 216 needs to go here, and I'm trying to figure out what that is, right? Okay. So you could do a proportion if you want to. You can multiply by 8 and divide by 5, right? So 5x equals whatever that number is, blah, 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 and then divide by 5. And it should be a number that's larger than 216, right?
345.6.
345.6 meters.
So you have that right.
There you go. Yep.
Oh my gosh, I'm so stupid.
Yeah, you're good.
I'm going to go.
That is 48. You just do whatever you want. Okay, how about that? That was 44 and 48. Yeah? All right, resume 1-4 notes. We are on, average rates of change. Hey, we talk about that a lot. We are in, right below example 5. And how much do we have left? Oh, not too much. Like page and a half. Okay. Average rate of change. We are talking about this a lot we're talking about instantaneous rate of change in calculus, right? Instantaneous rate of change. What does rate of change correspond to? Slope. So when they ask for average rate of change, they're just asking you to calculate the slope, all right? They're just going to give it to you in weird format, but that's fine, right? So here we have a medication concentration versus time. So after you take a pill, right? Let's say it's Tylenol, right? After you take a pill at time 0, then this medication in your bloodstream goes way, way, way up, right? It releases into your bloodstream, and then over time, you metabolize it, and the medication goes down until you need more medication again, and then you're going to do one of these again, right? Okay? And there is that. Got it? That's... Well, if it's an addictive drug, right? But if it's Tylenol, then maybe, not, whatever. Okay? So that's how that works. Got it? Okay? Now, secant line... we talked about tangent lines in calc, but a secant line is a line that goes through 2 points, right? So if I'm looking at, from here to here, I want to know the slope. I'm going to pick a point right here, and I'm going to pick a point right here, and I'm going to draw a secant line, and I'm going to estimate that slope using those 2 points, right? y2 minus y1 over x2 minus x1, I can figure out the slope. Now, the curve is actually this blue line right here, so it's not going to be exactly the correct slope, but it's going to be the best estimate, right, of what that is, right? For now, right? Okay, so they say determine the average rate of change meaning slope, of the concentration from 0 to 1, okay? Now, I'm going to put this in terms that maybe is a little bit easier to understand. They say x1 is 0 and x2 is 1, okay? 0 comma what and 1 comma what, right? Let's look over here. 0 comma 0 and 1 comma 0.06, okay? And I'm finding the slope of those 2 points. So after they give it to you this way, maybe put it into 2 coordinates. And then that makes it a little easier, right? So if I do y2, what's your y2 going to be?
So
0.06 minus 0 over 1 minus 0. 0.06 minus 0 is 0.06. And 0.06 divided by 1 is still 0.06. So your slope is 6%, basically. It's going up 6% over the course of an hour. Yeah? That doesn't seem like a very fast-acting medication. 6% in the first hour? That doesn't seem like very fast, right? Whatever.
6%
Right. No, normally it goes up really fast and then it tapers off.
Yeah,
But
math is a lot better.
this is maybe this is like a slow release. Have you guys ever taken a slow release? Like allergy medications are a lot of times slow release, like a Mucinex that's supposed to be like a 12-hour, right? It's a slow release, so it might not get the effects right off the bat, but like maybe a couple hours into it, you're finally feeling like your congestion is better, right?
Well, you
Okay.
don't want 100% in flow.
Right, true. Like, yeah, like, I don't know. Depending on what it is, though. B, I'll do B down here. They say from 1 to 2 now, so 1 comma something and 2 comma something. Those are my points. 1 we said was at 0.06. 2 was at, I don't know, 0.09. Okay? So if I do y2 minus y1, 0.09 minus 0.06 over 2 minus 1, which is 0.03 over 1, so that is a change of 3% or 0.03. That's the slope for part B. And then it says interpret the results from part A and part B. Actually, when we said it was 0.06, I said that's not a very big change, but that is the steepest change you get, right? Okay, so it's increasing when in part C it says interpret, so increasing faster rate from 0 to 1 than 1 to 2, right? It's increasing a lot faster initially, and then it's kind of tapering off, right? So it's increasing at a faster rate from 0 to 1 than it is from 1 to 2. That concentration is increasing faster. That's what part C is asking. Good, good? Not too bad, right? All right, 7. Given the function, so now we don't have a graph to look at. Now we have this function right here, x squared minus 1, that's a parabola. Determine the average rate of change, which again means slope. But they say from -2 to 0. Now, everybody real quick, look at this real quick. I know on your homework assignment that instead of saying from -x1, -2 to x2, 0, they will write it like this. They will write it in interval notation, okay? That just means you're going to take this and you're going to know -2 something and 0 something, right? So instead of saying x1 is -2, x2 is 0, they might write it in this interval format. That's totally fine. That means the same thing. You're going to come up with your two ordered pairs, right? So how do I figure out what the y coordinates are? Plug them in. So if I plug in -2, what's -2 squared? 4 minus 3, 1 is 3. 0 squared minus 1, -1. Now I do my slope. y2 is -1 minus 3 over 0 minus -2, or 0 plus 2. So this is going to be -4 over 2, which is -2. And we don't have any units, but it might be like -2 feet per second or -2 degrees per hour, whatever, right? But -2 is the slope, right? So just warning you that instead of doing this, they might do this instead, and that's just going to tell you where your starting and ending point are. Got it? Not too bad. Not too bad. Yeah, this next one is going to involve maybe some shading. So example 8, solve the equations and inequalities graphically. Oh. Okay. I don't, whatever. We can do this. It's fine. It's fine. Okay? All right, solve the equations and inequalities graphically. We're not going to solve anything. We're going to leave them together on the left and the right side. So on the left side, I'm going to graph 2x minus 3. We start at -3, and we go up 2 over 1, up 2 over 1, up 2 over 1, and I'm going to graph that guy. And I'm going to graph the other one also. Like that. That's what the pink guy looks like. Normally, we would solve for x, right? Okay, but we're not going to do that, because they want us to do it differently. X minus 1, now I'm going to graph that one. So I start at -1, and I go up 1 over 1, and up 1 over 1, and up 1 over 1, and up 1 over 1, right? And I do that.
Bless you.
And I do that.
Wow.
Okay? And then they say solve. What are we solving for? What's the answer? Particularly we're solving for x. What's the x going to be equal to? 2. We're looking for just the x coordinate, so 2. Okay, that's where they intersect each other. Now, if I were to take this equation and I would subtract the x over, right, this would be x, and I add the 3 over, I would get x equals, not 3, x equals 2, right? Okay, but they're just showing you in graphical format, that's what this looks like. Got it? Okay. Okay, next, Let's do this one. 2x minus 3. Oh, that's the same functions again. Okay, 2x minus 3, up 2 over 1, up 2 over 1, up 2 over 1, blah, blah, blah. Like that. There's that. And this one is minus 1, so we're going like this. Oh, gosh, I can't.
Only if we could do that on our computer.
I know. I can't. Something like that. I don't know. Right there, like that. Okay. Now, here's the deal. Are you ready? Let's talk about this signage right here. Okay? All right, the blue one was this one right here. The pink one was this one. I want to know where the blue one is less than. That's what the symbol says. Where the blue one is less than the pink one. Where is the blue one less than the pink one?
Below.
Right here. Okay, and that is as long as x is what? Less than 2, right? X at 2 right here. If x is less than 2, that blue is going to be below the pink. Does that make sense? X is less than 2. You would get that if you solved that thing, right?
Yep.
You would get x is less than 2, right? All right, now we're going to do this one. And this is, I think, the same thing again, right? I'm going to go the blue one. Woo. Blue one, minus 3, up 2 over 1, blah, blah, blah. Come on. Something like this. I don't know. Oh, gosh. Right there, like that. The pink one, minus 1, up 1 over 1, blah, blah, blah. Whatever. Something like that. Whatever. Something like that. Okay? Now, I want to know where the blue one is bigger than the pink one.
Above.
Yeah, where the blue one is bigger than the pink one is right here. Right? So right here is where it divides at x greater than 2 is where he is bigger than. That makes sense? Yeah? Okay? So again, you could solve that like linearly, like subtracting the x's, doing all the things, but visually, that's what they have for a graph as well. Got it? Okay. Hold on.
Oh, geez, well,
We're gonna teach some.
Fine, I just get looked at.
Dylan and Lauren, you're supposed to, the machine is ready, you're supposed to load trays when you can. Okay, no. All right.
Hey!
I looked at you. Okay, hold on just a second. Let's finish this guy and then you guys can go.
I was doing it for you.
Can we just do this linearly? Like and solve, not graphing. Let's do that. I don't care. Okay, so this guy, if I write him out, 6x minus 2, x plus 2 minus 5 equals 0, blah, blah, blah. I'm going to solve. Let's distribute. Don't forget. Negative 2 through 6x minus 2x minus 4 minus 5 equals 0. That is 4x minus 9. 4x equals positive 9, and x equals 2 and 1/4 or 2.25. Okay, that was for A. B, when they say this less than symbol, so I've got all the junk is less than or equal to 0, right? Then eventually I will have 4x is less than or equal to 9, and I'll have x is less than or equal to 2.25. Okay? C, same thing. I will have all the junk is greater than or equal to 0. I will have 4x is greater than or equal to 9. I will have x is greater than or equal to 2.25. And we just solved it that way, right? Okay, since it's the same thing. Happy with that? Not too bad. Okay? All right. There we go. Okay? You guys have the homework problems for those if you don't already have them done? You get some time to work. We will stop after 1-4 and we'll do bench upper quiz. So I'll give you that review tomorrow and then we'll quiz on whatever day it is. Thursday. Okay? All right. Goodbye.